Hello all, this is the solutions to the Unit 1 quiz. I know I've had several people with questions about it since you are able to see the solutions, but maybe you're not sure how to get those solutions. So I'm going to work through the entire quiz here, and now these problems may not be exactly like yours, but they are going to be similar. They're going to be the same kind with slightly different numbers, so you'll see how you should work them. So I'll go as efficiently as I can to not take up too much of your time. I've got a printout here of the test in order, so let's get to it with number 1. Find the GCF of the list. Those of you who missed it, well, you missed it for several different reasons, but as I look at this, I've got to find the greatest common factor for 45 and 75 to start with, because there's got to be a whole number part. Okay, so 45 and 75, let's think about that first. One way to think about this is to factor. Let's think what goes into 45. Well, I could do 15 times 3, and then 15 is 5 times 3, and then with 75 I could do 25 times 3, and then 25 is 5 times 5. So what I want to do now is I want to pick out what I see in common, or what do they share. Well, they each have at least one 3. There it is. There's a 3 in both of them. And they each have at least one 5. That's what they have in common. Right, so 5 times 3 is 15. That tells me that 15 is the biggest number that will go into both 45 and 75. Okay, so my GCF, now for my answer, the GCF is 15 something. Well, now I've got to deal with the letter part. Okay, well, I've got in my first, and I hope you can read this may have gotten a little fuzzy by the time it gets produced in YouTube, but this first number is 45, a to the 8, b to the 4th, c to the 8th. And then I have 75, a to the 9th, b. Okay, well, I can't have more than 8 a's because there's only 8 a's right here in this first term. So a to the 8th is the most I can have. And then b's, well, I have 4 b's in the first term, but I've only got a single b in the second term, so I can only have a single b on my answer. And I cannot have any C's. Several people included C in their answer, but the problem is the second term has no C's. So that's not a common factor. There's no C's in the second term. You can't include it. So my answer for this first problem is 15, a to the 8th, b. All right, moving right along. Number 2 tells me to factor by grouping. Okay, well, I'm going to start then by grouping because they've already got it set up for me. I'm going to group the first 2, and what I'm going to do, because I have a minus 9x here, I'm going to rewrite that as a plus a negative, because that's going to make it easier to group and not forget that there's a plus sign in between these parentheses. Okay, so what can I do? Well, in the first pair, what can I factor out? They're both divisible by 4, and they also both are divisible by x. So if I factor out a 4x, I'll just put a big equal sign here. What does that leave me with? In the first term, 4x squared, if I divide it by 4x, x is all that is left. Minus, if I take 12xy and divide it by 4x, I have 3y remaining. Okay, now, let's keep in mind that we want this pair of this parentheses, what's in here, this x minus 3y, we want it to match this one over here. We want it, after we factor the second pair, we want them to look the same so that we can factor out the parentheses. So what can I factor out of the second pair? Well, one has an x, one has a y, so I can't do anything with the variables, but they're both divisible by 9, and if you're paying attention to the signs, you see that I can factor out a negative 9 to make them look the same, because now that leaves me with x minus 3y after I divide both of those terms by negative 9. And now, since I have this x minus 3y, I have an x minus 3y here and an x minus 3y here. I can factor that out of both terms, and that gives me x minus 3y times, Well, what's left? In the first term, all that's left is 4x. And then in the second term, all that's left is minus 9. And there it is, factored by grouping. All right, there's my answer. Let's keep going. Number 3. First thing you should notice if you're going to factor this out is that all 3 terms are divisible by 2. So that should be your first step. Divide everything by 2. If I divide everything by 2, what's left is x squared plus 26x minus 27. After I divide all 3 terms by 2. Now I can factor what's inside these parentheses here, and that is, don't forget about the 2 out front. Several people factored it out and then left it out of their answer. I need to figure out what numbers multiply to make 27 or negative 27, but when I add them I get positive 26. Well, then that would be x plus 27 and x minus 1, because 27 times negative 1 is negative 27, but 27 minus 1 is 26. And there's my answer for number 3. That one was pretty quick. Number 4. The only thing maybe tricky here is that you need to switch it around. You're not used to seeing it written in this order. So let's rewrite it. Addition is commutative, so we can rewrite it in whatever order we want. So let's move the t term to the front, leave the 15t, sorry, there goes my pen going stupid on me again, in the middle, and move the 18 to the end. Now you should notice all of these are divisible by 3. So that leaves me with t squared plus 5t plus 6 after I divide all 3 terms by 3. And don't forget that 3 is still there out front. So I have 3 times. Now this is an easy one to factor. What numbers multiply to make 6? But when you add them, you get 5. That would be 3 and 2. T plus 3, t plus 2. And there is my answer. Alright. Moving right along to number 5. This one, a whole lot of you got wrong. Number 5, I think most of you that got it wrong chose option B, the polynomial is prime. You just assumed, because you don't see anything you can factor out there, that it can't be factored. But you forgot to see if you can do factor by grouping. Remember, let's start by doing A times C. Alright, well, what's A times C in this case? It's 11 times negative 3, which is a negative 33. So we're thinking, are there any numbers, any factors of 33 that, since it's negative 33, if one's positive and one's negative, I add them, I get negative 32. Well, yes, there are. Negative 33 and positive 1. Because if I do negative 33 times 1, I get negative 33. And if I do negative 33 plus 1, I get negative 32. So what I want to do is, in order to do factor by grouping, I'm going to take this and I'm going to split up this middle term. So I still have 11x squared. But then I'm going to take my middle term and I'm going to split it into a negative 33x and a positive 1x. And then that minus 3 is still there on the end. Now that I have done that, I can group. I can bring in my parentheses here and group this thing. And now look at the first pair. What can I factor out? They're both divisible by 11. They're also both divisible by x. And what does that leave me with? It leaves me with x minus 3. Now notice that this parenthesis I have here, x minus 3, already matches the second parenthesis. So I can't really factor anything out of the second one, but I can always factor a 1 out of anything. And so now I have a common factor here of x minus 3 in each term. And now I pull that to the front, leaving me with x minus 3 times 11x plus 1. Because I have 11x remaining in the first term and just 1 remaining in the second term after I divide by x minus 3. So there should be my final answer for number 5, rather than that it is prime. Okay, number 6. Number 6 is pretty quick once you get the m out of there. Notice that all 3 terms, here I have m cubed plus 4m squared plus 4m. Well, all 3 terms are divisible by m. And once I factor out the m, I have m squared plus 4m plus 4. And now that is easy to factor. That is m times, now the computer, well, I'll get to that in a second. What multiplies to 4 and adds to 4? 2 does. 2 and 2. M plus 2, M plus 2. Several people had 2 of the 3 parts here. This should be your final answer. Now the computer wants you to write it like this. They want you to write M times M plus 2 squared. But it's the same thing. If you write out the M plus 2 twice, I would have given you credit for it. It means the same thing. But several of you either forgot the M on the front, or you only wrote M plus 2 one time. Or you should have had it twice. So that should be my solution to number 6. Number 7, factor the binomial completely. The only thing tricky here is that this is written backwards from what you're expected to see. You're used to seeing it the other way, not negative 64 plus x squared. Well, just turn it around then. That's the same as x squared minus 64. It's the exact same thing. And then that's just very quick to factor. It's x plus 8 times x minus 8. And there's your solution. You're done. See, that wasn't so painful. Alright, now after 7, now we're getting into problems where you actually have to solve. Notice the difference is number 8 has an equal sign. I have negative 4x squared plus 36 equals 0. So now I'm looking to solve. Okay, well, what should I do first? First, I should realize that both of these terms on the left side are divisible by 4, or in this case, negative 4, because that's going to be more helpful. We want to get this negative 4 out of here, so let's divide. Let's factor it out. So I can factor this out, and it becomes negative 4 times x squared. Now what happens if I take 36 and divide it by negative 4? Well, it becomes a negative 9, is what happens. And this is still equal to 0. Okay, so if you realize you could factor out the negative 4, next what you should do is just divide everything by negative 4. Let's get it out of there completely. All right, that will cancel it out on the left side. And 0 divided by anything is still 0, so that doesn't change anything. So now my problem is x squared minus 9 equals 0. And hopefully you recognize that this on the left is a difference of 2 squares, easily factorable to x plus 3 times x minus 3. And now at this point, remember, if I get to here, zero product property says if these two things, here's one thing, one factor is x plus 3, another factor is x minus 3. Well, that was supposed to be a different color, but it didn't work out that way. Sometimes that happens. Let me fix that, though. I don't like that. I want it to show up different. So there's my two factors, x plus 3 and x minus 3. Zero product property says if I'm multiplying these two numbers and it equals 0, one of them, one of the two, must be 0. So that means there's two solutions here. One solution is if x plus 3 is 0. That would make the whole thing 0. The other solution is if x minus 3 is 0. And in each case, just do one step here algebraically to solve for x. Here we get x equals negative 3 by subtracting 3 from both sides. And here we get x equals positive 3. So there are my two answers, my two solutions to number 8. So what you would have typed in the box, if you were entering it in the box, you would have put negative 3, comma 3. Or 3, comma negative 3. The order you put them in doesn't matter. There were a lot of people who had right answers that I had to go back in and give credit for because you didn't enter it the way the computer was looking for it. But don't worry about that. That's why I go back and look at all the tests, and that's why several of you got quite a few points added to what you thought you did really bad on the test, and after I went through it, you didn't do that bad after all, because there were 3 or 4 questions that you got right, but the computer counted them wrong. Okay, number 9. Again, we have something that factors. X squared plus 10x plus 25 equals 0. Well, this on the left side is just x plus 5 squared, or x plus 5 times x plus 5. This one was a common one that people got wrong. Well, let's just solve it and then I'll show you why. These two factors are going to give me the same answer, obviously, because they're identical. So all I have to do is say, well, x plus 5 equals 0. What does that give me? That gives me x equals negative 5. Probably 8 or 10 people at least, maybe more than that, came in here and put, for your answer in the box, you put negative 5 comma negative 5 because you got it twice. Both factors gave you the same answer. But notice the directions, and these were here on your quiz also. Type each solution only once. Okay, so when you have repeated solutions, you don't need to type it twice. You just need to put it one time. And so that's why a lot of you originally got number 9 counted wrong, because you did this. You entered it twice when you should have only entered it once. And the computer is not smart enough to realize that that means the same thing. So that's why I came in and gave you credit for it. So there's only one solution to number 9. Number 10, find the x-intercepts. Now, again, I'm going to point out, anytime it asks you to find x-intercepts, and here it is in the directions, type an ordered pair. You should be entering an ordered pair, which is, remember, an ordered pair looks like x comma y in parentheses. Two numbers in parentheses, your x value and your y value. And if they're x-intercepts, then that means the y value will always be 0. But you have to enter them that way. You also need to use a comma to separate answers. Many of you just put the two answers in parentheses and did not put a comma between them, so again, it counted it wrong, which is dumb, but that's what it does, and that's why I come in and fix it. Okay, so, let me get rid of this, I need the space. If we're finding the x-intercepts, all we're doing is we're saying, we'll set y equal to 0. We want to know, where does this thing cross the y, or cross the x-axis? The x-axis is where y equals 0. Now this right side is easily factorable. Again, this is a simple trinomial to factor. Several of you also got your signs backwards on this one, so you got to be careful. We need numbers that multiply to negative 2. Okay, well, we've only got one option. It's 1 and 2. But we got to figure out which one gets the plus and which one gets the minus. Because when we add them, notice what happens when we add them. When we add them, they need to be negative 1, because that middle term is minus 1x. So that means that I should have x minus 2 and x plus 1, because negative 2 plus 1 is a negative 1. If you switch those signs, then you get it wrong, because you're treating it like that's a plus x in the middle, and it's not. So now take each of these factors, set them equal to 0. This gives me x equals positive 2, x equals negative 1, and then if I'm going to enter those as ordered pairs, I would enter 2, 0, comma, negative 1, 0. Now again, y'all's answers were probably different than this. Your numbers were slightly different, but it's the exact same process with different numbers. Number 11 is actually a terrible problem. A lot of you got this wrong, and I should have looked more closely at the answer choices before I selected this one. I did. If you go look at your test grade, I've added 4 points. I basically gave everyone credit for one question, because there were a lot of people missed 5 and a lot of people missed 11 and some others, but I gave you credit for 1 extra, gave you back 1. But the only thing that's really going on here that is the difference is the scales, and it's going to be really hard for me to show on here because I can't zoom in on these graphs like you could online. But if you'll notice the scales here, and you would have just had to see, everybody's would have been different. But if you got it wrong, you need to pay attention to how the x and y axis are scaled, especially the x-axis. What this tells us is that this graph is going to cross the x-axis at negative 2 and positive 3. So those are the 2 points it should cross the x-axis. Now this is why I don't like this problem, because these numbers are so big, it's not zoomed in very close. It's really hard to tell. But, for instance, if you take this first one, well, this is saying 90 out here. So that means that every one of these tick marks, if you count them out, I think there's 9 to get to here. That means every tick mark is 10. Well, that's really big and really hard to see exactly where it crosses, but that's not the correct answer. And then if you look at the second one, this is 60. Well, then that means we again have tens. 10, 20, 30, 40, 50, 60. And it looks like this first one is crossing at almost 10, but at least it's more than halfway, so it's crossing at maybe 5 or so. It's not right. The one that is correct, I'll just get to the right answer. C, in this case, is the right answer. Notice the scale here is only by 20s, so this first tick mark here is a 5. The second one's a 10. This third is a 15. The same over here. This is a -5. So this is the only one that's scaled to make the answer correct. But like I said, I basically threw that problem out. A lot of you got it right, but that was a bad question. That shouldn't have been on there. The answer choices were not very good. So I'm sorry about that. Moving on. Number 12, find the domain. Well, remember, the only thing that would affect the domain, well, first of all, if we had square root where if we had a negative number under a square root, because you can't take the square root of a negative and get a real number. But you didn't have any of those here. The other thing that affects the domain is the denominator. The denominator cannot be 0 because we can't divide by 0 unless you're Chuck Norris, and none of you are. So let's factor the denominator. What we have is x minus 6 over, this is a difference of two squares, so this is x plus 1, x minus 1. What is this telling me? Well, I've got two different values where the denominator would equal 0. If x is -1, the denominator would equal 0, but also if x is +1, the denominator would equal 0. Just by plugging it into either of these factors, you can see that that would be the case. Now, you have that information. What is that telling you? That is telling you x cannot equal 1 or -1. It cannot be either of those. Many of you had this correct and you entered it in a completely different format. You entered it in interval notation. I had several people who did this. You chose option A and then you put in for your answer -infinity to -1 union -1 to 1 union 1 to infinity. Now if you did that and you had the numbers correct and you had them in the right order, I gave you at least half credit. I gave you half credit for the problem, but you didn't pay attention to the format it was being asked for. The problem says x such that x is a real number and x is not equal to, all you were supposed to type in this box was 1, -1. That's all you were supposed to enter there. You did not need to do all of this interval notation business. All right, 13. Simplify. Well, that means we're going to be factoring. If you notice the top of the fraction, you have a 3, you have a 48. They're both divisible by 3. Factor out the 3 and you're left with x squared minus 16. On the bottom, 15 and 60 are both divisible by 15. So factor it out and we have x minus 4. Okay, now you're not done because, well, the 3 and the 15 can reduce, but also x squared minus 16 can be factored. So let me go ahead and reduce the 3 and the 15. 3 goes into itself once. It goes into 15 5 times. So this is just a 1 on top. I'm not going to write that. But x squared minus 16 factors to x plus 4 times x minus 4 over 5 times x minus 4. Now I have x minus 4s that cancel out, so I cancel out my x minus 4s and I see that my final answer is x plus 4 over 5. We had a lot of issues with this. A lot of people missed 13. I had a lot of people actually that gave me this as the answer, the numerator. You gave me the correct numerator without the denominator. I'm not sure what happened to your denominator. I'm not sure where it went, why it disappeared, but I had several people who did that. So if that was you, hopefully you can figure out what went wrong and why your denominator disappeared when it shouldn't have. All right, 14. It says multiply and simplify if possible. Well, before you multiply, you should factor, because here I can factor out an 8, and that leaves me with x plus 1. On the bottom, I've got a 5. I'll deal with the 5 and the 10 here in a second. I've got a 10 up here. And then down here, I can factor out a 32, which leaves me again with x plus 1. Alright. Now notice, I can do a whole lot of reducing here. X plus 1's cancel. 5 goes into itself once and goes into 10 twice. 8 goes into itself once and goes into 32 4 times. And now I can actually reduce even further, but I'll do that in the next step. So now all that's left on top, everything's canceled out except for 1 times, well really there's a 1 here, but that's okay. 1 times 2. And on the bottom, all I have left is a 4, so this reduces all the way to 1/2. 15. Now, of course, if you're going to divide, you know what Missy Elliott would do. You've got to change this to a multiplication problem when dividing by fractions. You've got to put your thing down, flip it, and reverse it, people. X squared plus 11x plus 28 over x minus 9. And now I'm going to, or, okay, the more boring version, right? Keep, change, flip. Change the sign to multiplication. Flip the second fraction. And now we can start thinking about how we can cancel out and reduce and all that good stuff. Well, you can see already, before I do anything else, the x minus 9s are going to cancel each other out. That's nice. Now that they're gone, let's focus on factoring the other two polynomials. This trinomial up here is factorable because 7 times 4 is 28, and 7 plus 4 is 11. So this can factor to x plus 7 times x plus 4. If my plus sign will work with me. Over, now let's look at this trinomial down here. Negative 12, but when I multiply I get negative 12, but when I add them I get 1. So I could use a positive 4 and a negative 3. X plus 4 times x minus 3, and that's how I would factor that trinomial. And then I have x minus 4's canceling out, so that my final answer is x plus 7 over x minus 3. If you're watching this and trying to compare your notes and your exact problem and you're not seeing exactly what you did wrong, how your numbers compare to my numbers that I'm working with here, feel free to email me your specific numbers or tell me which problem it is, and I'll look at, I can look at your specific quiz and see what the answer would have been to, or how you would have worked your specific problem with the numbers you had. Okay, 16. Now we are adding and subtracting fractions. Notice we're subtracting here. This minus sign is going to get a lot of you. We had a lot of issues with this. People lost their denominators completely in here. Remember, when you're adding and subtracting fractions, you don't get rid of the denominator. You want a common denominator so that you can add or subtract. Well, in this problem, we already have a common denominator. It's x minus 3. So let's just go ahead and combine this into one fraction. So I have negative 9x squared. Now, careful here. This is what got a lot of people. Minus 9. I'm subtracting 9. But what you also have to remember is this minus sign is distributed. It applies to the minus 10x squared also. So you have to say minus a minus 10x squared, which means plus 10x squared. I think that right there got a lot of people on this problem. And all of this is over x minus 3. Now on top you can combine your x squared terms. You have a positive 10x squared, a negative 9x squared. That's just a single x squared, minus 9. All of that over x minus 3. And then notice that the top can factor. That's a difference of 2 squares. That factors to x plus 3 times x minus 3. All of it divided by x minus 3. And so we cancel out the x minus 3's, and we see that our final answer is x plus 3. Moving right along. Number 17. Now, we want to add fractions, but we have to have a common denominator. So first, what I want you to notice is this denominator on the second fraction. Let's factor it. We have 2 over x plus 3 plus, it's supposed to be a plus sign there. What's going on? Come on, pen, work with me. 9 over, if I factor out a 3, I have 3 times x plus 3. So notice, what's the difference between my two denominators? The only difference is that this second denominator has this 3 right here. Okay, well, I can fix this. I can come in here to the first denominator and say, well, then let me multiply u by 3. But if I do that on the bottom, I also must do it on top. Remember, if I'm going to keep it equal, if I'm going to keep the fraction equal to itself, I've got to do the same thing on the top and the bottom. And now you'll see that they each have the same denominator. All right? So now this gives me 2 times 3 is 6 over 3 times x plus 3 plus 9 over 3 times x plus 3. Well, we can now add these because they now have the same denominator. So that's 9 plus 6 is 15 over 3 times x plus 3. And what do I need to do? I just need to reduce. 3 goes into itself once. It goes into 15 5 times. So my final answer is 5 over x plus 3. And there you have it. Okay, moving on to number 18. Another problem I saw a lot of. Really, this whole section with adding and subtracting fractions, the common denominator thing just gets people. Okay, this one is deceptively simple. It looks harder than it is. It looks weird because you've got a variable in the denominator. I have 7 over m plus 6. Well, remember that any whole number can be put over 1. So this is the same as 7 over m plus 6 over 1. Well, what's my common denominator then? Here I have a 1, here I have an m. So my common denominator is just m. What do I need to do to get an m in both denominators? Well, I need to come over here to this second fraction, and I need to multiply it by m. But if I do it on the bottom, I've got to do it on the top also, and my pen is really not cooperating now. I do not know what's going on. Let me try this again. No, my m's are going to look ridiculous if my pen's not going to cooperate with me. I promise I can make an m. Alright, there we go. Third time's a charm. Alright, I multiplied top and bottom of the second fraction by m, so that now I have a common denominator. And now I have 7 over m plus 6m over m. So now that I have a common denominator, I can add. I have 7 plus 6m over m. I think a lot of people combined those two things on top. You cannot do that. 7 and 6m are not like terms. You can't add them. You can just leave them like that with a plus sign in between them, but you cannot combine them into a single term. That is not equal to 13m. So we just have to leave our answer like that. Okay, moving right along. Flying right through the test here as quick as possible. Quiz, I'm sorry. Quiz. Alright, now this is where we want to finally get rid of denominators. Finally, we have a problem. We want to solve this equation. I want to solve it by getting rid of the denominators. That's the quickest way, I think, to solve it. Well, remember, I have this 6 here, which is going to be put over 1. And then what's my common denominator? Well, I have a 1 and I have an a minus 6. So my common denominator is a minus 6. I'm going to multiply everything by a minus 6. I'm going to multiply by a minus 6 here. I'm going to multiply by a minus 6 here. And I'm going to multiply by a minus 6 here. What does that give me? Well, in these other two fractions, the a minus 6's cancel each other out. So let me rewrite this now. I've canceled out all my denominators. I have a minus 6 times 6 plus 30, because the 30, the a minus 6 is canceled out, and I have that equal to 5a. Again, on the right side, the a minus 6 is canceled out. Okay, now distribute the 6. That gives me 6a minus 36 plus 30 equals 5a. From here, it's just a little algebra to get your a's together. If you want to subtract 6a from both sides, you don't have to. That's probably the quickest way to get there, but you could also, well, if you don't subtract 6a, you'll end up moving stuff around multiple places. I'll tell you what, first let me go ahead and combine this negative 36 plus 30. So this is 6a minus 6 equals 5a. So now I'm going to subtract this 6a from both sides, and I have negative 6 is equal to negative 1a. But I don't want negative a, I want a, so I'll just divide by negative 1, and I get 6 is equal to a. Now, if you did that and you gave me this answer, I gave you half credit, because a lot of you did this and you said, okay, the answer is a, circle in a and put 6 in the box. Here's the problem with that. You have to check your solution. Notice it even said it in the directions back up at the start of the problem, and check the proposed solution. What do I mean by that? Well, if you take a equals 6 and plug it into the original equation, notice what's going to happen. My original equation was this. Let me rewrite it here. 6 plus 30 over a minus 6 equals 5a over a minus 6. What happens if I plug in a equals 6? I get a bunch of zeros in denominators. So, in fact, 6 is not the answer. The answer is there is no solution, because the only answer I came up with does not actually work. I cannot plug in 6 for a, because it gives me a 0 in the denominator, so there's no solution. Tricky, tricky, I know. Alright, number 20. X plus 9 over 3 minus x minus 9 over 6 equals 7/6. Okay, common denominator. I have a 3, a 6, and a 6. So the least common denominator is 6. So let me come in here and multiply by 6 everywhere. And really you need to think about these two parts being in parentheses. We're multiplying by 6 on top. Now keep in mind, whereas before when we were adding and subtracting fractions, if we multiplied something by the denominator or the numerator, we had to do it to both, because that's the only way we could keep it equal. But here we have an equal sign. The difference is now I have an equation with an equal sign. So as long as I multiply both sides of the equation by the same thing, I'm good. It's still equal. So I don't need to multiply the top and bottom by 6 here. Okay, so what happens here? Well, I get some 6's canceling out. And then here, this reduces. This 3 becomes a 1, and this 6 becomes a 2. So what's my problem now? I have 2 times x plus 9 minus x minus 9. And you've got to be careful there with that minus sign. If you don't put the x minus 9 in parentheses, you're going to get that wrong. And all of that equals 7, because on the right side, the 6 is canceled. So now let me distribute here. I have 2x plus 18 minus x plus 9, careful there, that's a plus 9 because it's minus a minus, equals 7. So now just combining my like terms, I have 2x minus x is a single x. I have 18 plus 9 is a positive 27. And so all I need to do is subtract 27 from both sides, and I get x equals negative 20 for this problem. Alright, this is the part that most of you did very well on. 21, solve the proportion. This is probably the easiest question on the test right here. Cross multiply and divide. 9 times 2 is 18. 3 times x is 3x. Divide by 3, and we get x equals 6. Or 6 equals x. Same difference. Put a 6 in the box. 22, a bunch of people got this wrong. I'm not sure if you just set it up incorrectly or if you multiplied wrong, but let's see. I have a y here. The corresponding side is 19. Okay, so I could say y over 19 is equal to, if these triangles are similar, it's equal to, well, pick either of the other two pairs of sides. It's got to be in the same ratio. So let's say I pick the top side up here. This is 3.5. Well, then the corresponding side is 7. Now notice I have y on the top of my fraction on the left. That means I have to have 3.5 on the top on the right. I've got to have the same triangle on the top of each fraction if I'm going to keep the ratio equal. So I have y over 19 equals 3.5 over 7. If you had chosen to use the other sides, if you had chosen to use, let me use a different color here. If you had chosen to use 8.5 and 17, you would have gotten the exact same answer. You should come out with the same answer either way. Cross multiply here, and I have 7y equals, oh, whatever that is. Put me on the spot here a little bit. Let's see, that's a 5. 27, 32, 4 is 36, carried 3, 6. So that should be 66.5 is what that should be. Okay, and then we're going to divide by 7. And I'm not going to bother doing that math. I just know that it's going to be half of 19, so it's going to end up being 9.5. Yes, it is. I can verify that I did the math right there. 9.5 is what you should end up with for y. Now, if you're really astute and paying attention here, you could have done this without setting up this whole proportion and doing all the math. Let me come over here and show you why. Come back and look at these triangles. If you notice that 3.5 is half of 7, and you notice that 8.5 is half of 17, well then you would say, okay, y just has to be half of 19. So y is 9.5. You could have gotten that without actually going through the math of the proportion there. Okay, moving on. 23. Okay, this expert recommends there be at least 9 square feet of floor space in a college classroom for every student. Find the minimum floor space that 66 students require. Those of you who missed this, and quite a few of you did, you must have just had an issue reading the problem. I think in general math students have an issue reading word problems. Well, they're saying for every 1 student there should be 9 square feet. Then when you have 66 students, how many square feet do you need? That's essentially what the problem is saying. Or if you read it a different way, and I mean you're going to see this in just a second, all you're really doing is saying, well, each person needs 9 square feet. There's 66 people, so let's do 9 times 66. But when you cross multiply, that really is what you do, because you do 1 times x is just x, and then 9 times 66 is whatever that is. Let's see, 54, carry the 5, 59, 594. So the answer here would be 594 square feet. Of course, all you had to do was type 594 in the box. Okay, 2 more questions. I'm getting there. Okay, simplify the complex fraction. Remember, a fraction bar is just division. It's division we haven't done yet. So this is equal to 6 over 3x divided by 2 over 3x. Well, then we know we should immediately change this to a multiplication problem by changing the sign and flipping the second fraction. And now look at what you can do. There's a whole lot of reducing here. 3x and 3x just completely wipe each other out. They become 1s. That's a 1, that's a 1. And then 2 goes into itself once. 2 goes into 6 3 times. So after all that reducing, I end up with 3 over 1, which of course is just 3. And last but not least, 25. A little bit more involved. The way I like to work these is to get rid of the denominators first. Okay, so what I mean by that is the complex fraction has fractions within it. I've got a fraction here, 3/6. I've got 4/6 here. I want to get rid of those fractions by canceling out the denominators. Well, how can I do that? I need to figure out my least common denominator. Now in my problem here, it's kind of simple because I have 2 whole numbers and I've got 2 numbers that are fractions with a denominator of 6. So if I want to cancel out the denominators, all I need to do is multiply everything by 6. So here I go. Times 6, times 6, times 6, times 6. And what happens? Well, these 6's cancel, those 6's cancel. What am I left with? 6 times 1 is 6, plus, in this fraction here, the 6 is canceled, all that's left is a 3. And then on the bottom I have 6 times 4 is 24, And again, these 6 is canceled, so all that's left is a 4 plus 4. So on top I have 9. On the bottom I have 27. Well, that quickly reduces to 1/3. And hallelujah, we are done. Now again, please feel free to email me, call me, whatever, with a specific question from your quiz that you're still not understanding even after watching this video. But hopefully this clears up a lot of the confusion.